Hey guys, so in this video I'm just going to go over the solution to the one free response question that I assigned you for the week. This is 2000 from the 2009 exam. This is question number 4. So just rereading the problem, it says one of the two fire stations in a certain town responds to calls in the northern half of the town. The other fire station responds to calls in the southern half of the town. One of the town council members believes that the two fire stations have different mean response times. Response time is measured by the difference between the time an emergency call comes into the fire station and the time the first truck arrives at the scene of the fire. Data were collected to investigate whether the council members' beliefs is correct. A random sample of 50 calls selected from the northern fire station had a mean response time of 4.3 minutes with a standard deviation of 3.7 minutes. A random sample of 50 calls selected from the southern fire station had a mean response time of 5.3 minutes with a standard deviation of 3.2 minutes. And part A says to construct and interpret a 95% confidence interval for the difference in the mean response times between the two fire stations. So first of all, it says mean response times. So I know I'm going to be doing a confidence interval for means. So the next thing where I would kind of go from here is to decide if it's a one sample or a two sample or a matched pairs. Those are your choices for the test for means. So if we go back and read the problem, we're talking about taking a sample from the northern fire station and a sample from the southern fire station. So those are two separate independent samples. So this is going to be a two sample test for means. And then remember, if it's a two sample, the only two sample test for means we ever did was a T. And I can tell you right now that 95% of the time, if it's a test or a confidence interval for means, it's going to be a T and not a Z. Okay? Because even though we know a standard deviation, this is the sample standard deviation. So if you know the sample standard deviation, that's a T test or T confidence interval. So this is going to be a two sample T confidence interval. So I'm just going to go to this other page where I have my work. So since it's a two sample, we have two populations. My populations are the calls because they took a sample of the calls. So the calls to fire stations A and B. And then the parameter. Remember, parameter for us is always going to be mean or proportion. So in this case, it's the mean response time. So that's my step 1. Step 2, this is a two sample T confidence interval for mu. The conditions for that, the first one is SRS. Remember, SRS is just really to check that it is random. And they tell you back here a random sample of 50 calls. Okay, so that's a check, and you can just write given as the reason. Approximately normal. So remember, for means, the way you check approximately normal is either they tell you it's approximately normal, which they don't on this problem. Your second go-to is the central limit theorem, which works here, because your sample size is 50 for both of them. So 50 is greater than or equal to 30, and then just put CLT as an abbreviation. Okay. The only other option, if they don't tell you and CLT doesn't apply, is you would do a quantile plot. Okay, but you'd have to have all the data to do that. So approximately normal is met here. And then since it's a two sample, our third condition is that they're two independent samples. And they are. One is the northern fire station and one is the southern. Okay, so that's kind of our step 2, naming the procedure, checking the conditions. And then our step 3, okay, so this is the formula that we're going to use for our step 3. So it's the difference in the two means. And by the way, if you reverse these two, going to be totally okay. You're going to get these same values just with opposite signs. So it's the one mean. So the way I did it was I did it the north minus the south. So it's the mean of the north minus the mean of the south, plus or minus, and then this is your T star. Okay, so just a reminder how to get T star. It's under inverse T. So calculator, if you forget where that is, it's under second vars and then inverse T. Okay, so second vars, inverse T, and then it's 1 minus the confidence interval divided by 2. So you can see I put 1 minus 0.95 over 2, which is 0.025. Degrees of freedom is your sample size minus 1. Since it's a two sample, it's your smaller sample size minus 1, but that doesn't matter here because the sample sizes are both 50. Okay, so And I'm just going to round. Okay, and remember, you can just take the absolute value of that number to make it easier for calculations. So I'm going to round that to 2.01. So it's plus or minus 2.01. And then this is the formula for the standard deviation. It's the standard deviation of the one squared over its sample size plus the standard deviation of the other squared over its sample size. And remember, formulas, when you take the test, it's open note, open book. So remember, you don't need to memorize these formulas. Okay, utilize your notes. So when I do that and I plug it in, I get these two values. Again, if you reverse these two, your answers would just be reversed. And then my last step is to interpret. So we are 95% confident that the mean difference in response times is between negative 2.391 and 0.391 seconds for fire stations A and B. So it's the difference. Remember, anytime you're doing a two sample, you're really getting the mean difference in the response times. So that is part A. Then part B asks me, does the confidence interval in part A support the council members' belief that the two fire stations have different mean response times, and explain? Okay, so if we look at our confidence interval, it goes from negative 2.391 to 0.391. Okay, and in here we're estimating the mean difference in response times. And they're asking us, does it support the belief they have different response times? So the answer to this question is no. The reason the answer is no is because 0 is contained in our confidence interval. It goes from a negative to a positive. So no, the confidence interval does not support the council members' belief that the two fire stations have different mean response times because 0 is contained in the confidence interval. So what that means is that the difference in the response times could be 0, okay, since 0 is included in there. So we don't have enough evidence to say that there would be a statistically significant difference. It goes back to the idea of if your null is contained in the confidence interval, you fail to reject it. Okay? And our null hypothesis would be that the difference is 0. Since 0 is contained in there, we cannot reject it. So therefore, we don't have evidence that they are different. Okay, guys, thanks for watching, and I will talk to you soon.